All right. Let's focus for a moment. What we're going to be trying to do today is we're going to try to see if we can't make some sense about what we did. So we did three things. We did a bouncy collision, an explosion, and a sticky collision. Do you remember doing those? Yeah. Okay, I'm interested in first the bouncy collision. So let's take our whiteboards and let's put them somewhere where everyone can see them, but we're not hiding behind them.
Oh, maybe we already had it. Oh, so we're good. We can erase that one. I wasn't really paying attention. Not everyone.
It's because there's desks.
Well, that was the whole point. Like, you have to hold them so...
Well, hey, I'm sorry. But I'm blocking me.
There you go.
Then you can't see me.
I know. Don't do that.
Okay, I'm fine with that.
So here's what I'm interested in, okay? Really, the whole goal of this is to try to figure out how... So let me start again. So we had one car. It was moving. It hit another car. What happened to the original car after the collision? It did not blow up. No, I like that as an idea, though. Did it slow down? Go back to the bouncy collision. Does the first car slow down?
Yeah.
It does, right? So what would you say happened to its momentum?
It went down.
I would agree. I think it decreased. If you look on the front board, momentum has two concepts. Okay, there's two frameworks for momentum. One, mathematical, is like if you want to calculate the momentum of an object, you need to know its mass and its velocity. But also, conceptually, momentum is a measurement of how difficult it is to bring an object to a stop. So if you had more mass, it would be harder to stop you. That'd be more momentum. But also, if you're moving faster, you would have more momentum. Okay? So first car slows down, loses some momentum. What happens to car 2? If car 1 slows down and loses momentum, what happens to car 2? That's right, it's sped up, which means it gained momentum, right? So I think the inherent question is, how does the amount that of momentum that 1 loses compare to the amount that 2 gains? You with me on that? And then to understand this, what we did is we're going to try to analyze the total amount before and the total amount after. To get the total amount, all you got to do is add them up. So I would like you to check your board, okay? I would like you just for the bouncy collision, okay, just for the bouncy collision. And I'd like you to decide, how does the total momentum before compare to the total momentum after? It's either going to be greater than, less than, or equal to. All right, check your neighbor's meow.
No, it's going to be.
No, not quite.
I do have little p's equal.
They're
different. It's not the same.
All right, what do we think? Annabelle, you got to have an opinion. You do. I could hear you talking. Tell me what you're thinking.
Nope.
Lizzie, I know you checked your neighbor. What did your neighbor have to say?
I think it's less than.
Think it's less than. Okay. What's your original? You have 0.655 and 0.459. That seems less than. Okay. What about you guys over here? Madeline, what do you guys have?
Ours is after the collision.
It was what?
It's like basically almost the same. Well, because we rounded up.
So put your board a little bit more vertical so the camera can see it. I was getting nothing but glare. So what's your momentum beforehand? 493?
Yeah.
And after it's 506. Those are points, right?
Yeah.
So it's a difference between 493 and 506.
Pretty close.
And so what do you want to suggest then for us? You want them to be equal. Okay. What do you guys think?
I think they're also
The
equal.
same thing.
Ours are pretty close enough.
But I mean, it's 0.458 or 548 and 0.513.
Yeah.
They would still round to 0.5.
Well, technically, they were both round to 1, so we could just call them the same. It's fine. What's happening? Grace, what was that?
We just agree with that.
Oh, Lauren.
No, it didn't hurt.
Okay,
It's like I didn't know.
it's very surprising when you get in that. Okay, so what were you guys saying?
We were saying for real.
What, for real? What for real?
They'd both round to 1.
It's like all of your grades really round to 100%. So really, isn't everybody just getting A pluses?
Round my grades, it would make my life so much easier.
Well, I shouldn't say that. That's not everybody's grade. Some of them round to 0. So if we were rounding there, we would, you know.
I'm still down around.
So Grace, what do you guys think? So I'll summarize and you can tell me what you think. They said, look, over here, the second group here says, ours are actually really close. We think they're probably supposed to be the same. This group over here said, ours aren't actually really close, but we think they should be the same.
Well, ours are not close, so I don't think they're the same. They're like 0.03.
Yours?
These ones?
Yeah.
That's like point.
All right, hold on. Hold on.
Error for us.
They're the
Right?
same.
Am I doing math right?
No. Let's listen to Lexi. Go ahead.
They're only like 0.03 away from each other. That's not like a huge significant difference, is it?
But it's 0.03 out of your number is 0.5, right?
Yeah.
So it's what, 6%, 7%, 8%?
Oh. I can't do that.
Happy with that margin of error.
Okay, well, let's do this. I actually think that I'm not ready to say one way or the other. I think it's a little inconclusive at this point. What if we looked at the other two scenarios and tried to say, like, given what we see in the other two scenarios, it sheds more light on this scenario? Does that seem reasonable? All right, so let's look at the collisions. Okay? Let's look at, well, actually, you know what? Let's not. Let's look at the sticky collisions. The sticky collisions. Okay. Swap your board if you need.
Technically, like this one is lower. But they're doing like
Solid 30 seconds.
that one's lower, that one's lower. Go! But they're close.
I'm getting there.
Ren, can you coach us up? What do you got here?
So far as they're close to each other for our total amount.
What's your total momentum beforehand?
Our total momentum before is 0.485, and then our after is 0.459.
So that's the difference here is 0.025, 26.
Want to get that technical.
Well, I'm just. What do you want to say about it though?
They're basically the same.
You want to go with that's the same. Okay. What do we have over here?
0.518 and 0.504.
So this is 0.518 and 0.504.
0.01 power difference, right?
That's 0.0. That's. I mean, we're talking about a 0.2 difference out of 0.5 or 0.02 difference out of 0.5.
Less than
It's a
6%.
0.014 difference.
That's pretty small.
Yeah.
Okay, that's pretty small. What about over here?
It's very small.
She said.
So your total before is point. Oh, did you can't. Did you work in grams?
Maybe.
Okay, so
It's like it's their first day. Like, hey, listen, we're gonna work in grams and inches in here today. I think that's the.
So it'd be what, 0.9
Yeah, so, but it's just 1,000. So what's your
0.414.
0.414 before, and what about after?
It would be 0.414 after.
So he's got 0.414 before and 0.414 after. All right. What do you guys think now? In what way?
I feel like it's too close together.
It's too close together. Like they made up their data because they wanted to fit their already model. Like I think they should be the same. Let's just write down the same number twice
Yes, because that's what
and try to convince Mr. Patta that we did it.
It feels too good to be true.
Okay. So, but for real, given this set of data, are we more zeroed in on a conclusion or less zeroed in?
Less.
More?
More because it's the same or the closer.
Thanks for trying to say it's equal.
We have more evidence that they're close.
Okay. Danny, you said something. I want to hear what you said.
So are we zeroing in on the fact that they're equal? And then theirs were like really close, almost suspiciously close. I don't know.
And Lexi, you echoed that comment, yes? You said, we're getting closer to having a sense that they probably might be equal, even given this group's bad data from Lab 1. Well, it just doesn't, everyone else's looks really close together and yours is like super far off.
But Brendan was there that day.
That is true.
Yeah, Brendan's.
Brendan's full.
So let's look at the explosions then.
Oh, explosions. I was like, what? Let me switch my board again. You could have just made me do this one first.
I know, I'm pretty horrible.
Oh my god. Now, I gotta take this back and then put it back on base.
You gotta hold it over your desk because I can't see your number.
Why do you want to be so you have yeah, that makes sense because you have to add together the loss.
For this one.
It's zero for both of them before, but not after. They're always. Why is he glaring so big?
No, I think he's trying to figure out. It's the bottom one.
We're done.
All right, let's look over here. Now, this one was a little different, right? So we had your two cars, we pushed them together, and you let them go. What was the velocity of each car at the instant that you let it go? 0, because you didn't push them, you let them go.
Yes.
So if you look at the chart here, we say velocities are 0 before they're pushed apart, which means the momentum was 0 before they were pushed apart. So what's your total momentum initially? 0. I think everybody's got 0 there. I feel good about that, right? Now, what is your total momentum after?
-0.08.
So negative 0.08. That's a very small number.
We didn't do anything.
Now,
I don't know, that's just what happens.
this seems a little different than this group over here.
Sorry though, our data is suspicious.
And what do you guys have over here? Your initial 0, what's your final?
57.1, I believe. Remove that over 3 decimals.
.057.
Yeah, what was he said?
Hmm.
I think we might be wrong.
We might be a little moving out loud.
Well, there's actually something missing from your boards that I see on some other people's boards. Okay? One thing I'm noticing is like in the bouncy collisions, you push the car to the right, it hits, it keeps moving to the right, the car that gets hit moves to the right. Everybody's positive velocity. In the sticky collisions, you push a car, it's moving to the right, it hits a car, they're both moving to the right, all velocities are positive. But what happened in the explosion? You push the two cars together and let them go. One car moved to the right. What did the other car do? It moved to the left. Do you have that represented on your board? They do, because
Set that in the pre.
I know.
So good.
One of their cars is moving left, so what should be true about one of their velocities? It should be negative. Do you have any negative velocities on yours? No. So we might have to make some edits.
I love my group.
Okay? So we're going to be out of time here in a moment. All right, we'll have to pick this up on Monday.
Don't erase my group.
But I want to make sure that if we need to save these boards, if you need to make some edits like negative velocities and then recalculate your total momentums, make sure you do that now before you go today.